coworker Ansgar, and I'm very happy that we are doing this session today. So we are going to talk about AWS CDK Constructs in CDK for Terraform, and that's a project which was primarily led by Ansgar. So Ansgar, perhaps you can say like a few words about you and set the stage for what we're doing here.
Yeah, thanks for having me. So I'm Ansgar. I also work on the CDK for Terraform team at HashiCorp. And yeah, besides the usuals, yeah, the AWS adapter, or this new thingy kinda, was my main project that I spent like the last month on, or a bit more. And I'm very excited to show it to you. And yeah.
Awesome. So yeah, so like this was released with the last CDK for Terraform version, which when was it again? Like 2 weeks ago already?
I think, yeah.
And so we, it's like a technical preview. So it's like a really early version, and
you will see that.
we will see that in a second. And perhaps we can just
Oops.
Yeah. Perfect. So that's like similar to the pre-built providers which we have in CDK for Terraform. That's also like the interoperability layer between the AWS CDK and CDK for Terraform is also like a dedicated project. And so that's essentially the like separate from the main repository. And so Ansgar, like what is it actually using to make this happen? Since like AWS CDK is using CloudFormation, CDK for Terraform is using HCL, like the actual Terraform providers under the hood. So what made it?
Well, we could have done this before, and there was a prototype that this is based on that appeared prior to now, kind of. But the main thing that enabled us to do this in a more feasible way was the AWS Cloud Control API that was recently released, I think a month ago or 1.5 or something. And the AWS Cloud Control API takes resources in the same schema as CloudFormation. So we could take the CloudFormation output from the CDK, from the AWS CDK, and basically pass it on to the Cloud Control API. And in the AWS Terraform AWS provider, there's also this new resource. And yeah, we could kind of push it from the left to the right by the use of that new API.
Right. So the Cloud Control API, so that's essentially like the service which got released like a few weeks ago, a few months ago or so. And that's essentially like what CloudFormation is using behind the scenes, correct?
From what I've heard, yes, but I'm no expert on that matter. Okay. I think that uses the same API that CloudFormation also uses. But what I know is that the schema is the same. So
the schema is the same, okay.
Yeah.
Okay, and there are I think you mentioned this already, there are like a few limitations around this. So it's like not covering all the APIs or like not all the resources at the moment, the CloudFormation API. Cloud Control API. Which we also see like in the project which we are going to do, or like a little example, like which kind of implications this has. But yeah, it's a long list, and it's a growing list.
And it's growing, yeah.
it's not complete, right? So it's like not the entire spectrum of all the AWS services. It's just a subset at the moment. And unfortunately, like a few important services are missing, like long-standing services like identity and access management. S3 is still missing, I believe. Or like
I think it was added on some part of S3, but I think just some
right. Okay, it's like only like probably it's like
the first resource to try out from that team, maybe. Yeah.
Okay, cool. Okay, I mean that's all details here, and I think this becomes more relevant when we can see the actual example. So I took the liberty to create, or like to take one example out of this repository here. So when you see the CDK-TF AWS CDK project on GitHub, there are like a few examples which we like use for like testing and demoing and stuff. And I took the cron lambda example. So I didn't really have to write any of this besides from creating like the project itself. And so what we are seeing here is like a CDK for Terraform application. So I created this with the CDK-TF CLI, just did a plain init with a TypeScript template. And then just copied your example, which you wrote into the project. And I mean, what we see here is we are using the version 2, like the upcoming version 2 release of the AWS CDK library, which is essentially like a mono package, in contrast to the version 1, where each of these services would have been distributed as an individual package. It's now like packaged up as one single package. And so we're targeting only this release. We don't support any release prior to this. And besides from that, we're just using, not just using, in this case, we're actually using a very specific version of CDK for Terraform.
That's right.
But this is due to the fact that we have, that's like, like a pre-release, and it's like heavily work in progress. So,
yeah, we're living on the edge there. So the bleeding one. That's right.
Yeah, exactly. So we see here it's like a very specific version of this, a very specific version of the CDK lib. I wasn't really sure. I haven't tried like any newer version.
That should work.
That should probably work, right?
Yeah. So that's not that fixed for the CDK-TF lib. It is, but that's only due to some improvements or features we had later on that were necessary. But
right.
Yeah.
Okay, so from that sense, it's like at the moment it's totally fine for playing around and exploring what we are doing here. But using this in a production context, I would wait with that like a bit until this gets like easier to handle in terms of versions and upgrades and stuff like this. Yeah, so we actually have the native AWS CDK lib version 2. We are using CDK-TF, and we are using constructs, the constructs package, which is then used which is a common, bridge behind CDK-TF and AWS CDK, right? So like it's like a common package which we are using here.
Yeah, and I think I'm not sure whether the AWS CDK version 1 also uses constructs version 10 already, but
I believe so, yes.
Okay, we had to update constructs because we had to use the same version because they coexist. So CDK-TF and the AWS CDK lib, they both depend on constructs, and we were on version 3 back then when I built this, and then we had to upgrade. So we're on V10. I think it's a dependency.
Well, it's a direct dependency, right?
Yeah.
Yeah, okay.
The AWS adapter itself also depends on this.
Okay, yeah, cool. Okay, cool. So we have sorted out our direct dependencies, and then let's take a look what we are seeing here. So we have a stack. We have, like, in terms of resources, we have a Lambda function, and we have an events rule, and that's pretty much it. So these are two resources which we are actually using directly from the AWS CDK library package. So it's like an AWS CDK construct which we're using here. Yeah. Correct?
Yeah, that's right.
Yeah. And like when we're looking at this and compared to like a normal CDK for Terraform application, one thing which stands out is this thing here. And well,
that's where the magic happens.
That's where the magic happens. Okay, so that's like the magic thing which makes everything beautiful.
Yeah, and something that you can quickly overlook is that, for example, line 21, you pass that AWS adapter as the context to the AWS Lambda function.
And not this.
So yeah, usually you would write this, but with the adapter, you instantiate it in the scope or the constructs tree of the adapter. So they are actually separate. So if you have if you walk the tree of constructs in the CDK TF, and then in the AWS Terraform adapter, you will find different constructs. So they are separated there. But this adapter, I could go into the detail there, but this then
but like what people might ask, or what I was just asking myself, is why can't I do this? Like, why can't I just extend, like, rather than using like a Terraform stack, what is, like, would this, or like perhaps it works? I don't know.
I haven't tested it. So coming from TypeScript, I usually at first, and having done a bit of React in the past, I usually look at functional composition and other ways of doing that first, then inheritance. So my Java days are way back, years ago. So that's maybe why I was not so inclined to have a look at this adapter part.
No, just out of curiosity. So like
it could work, but then we would, the adapter does not extend a stack, so you wouldn't have a stack. But I'm not sure whether it actually works. Haven't checked it. But from the from this perspective, or from this example, having the adapter separate allows you also to combine Terraform CDK for Terraform constructs and AWS CDK constructs, because if you now would use like Terraform output or Terraform variable, you couldn't instantiate it with this. You would kind of need to find out which stack this is going to be in later on, and this way you could either use this or the AWS adapter to instantiate.
Yeah, that makes sense. So it's like so I just have to keep in mind, okay, that's like my adapter, that's my my context, my host for these for like everything which is related with AWS CDK constructs. And by doing this, I can still go and, I don't know, add some whatever, like Datadog provider, or have it all the same stack, even though we are using like foreign resources, foreign constructs. Cool. Okay. Well, that looks pretty well. So, and I mean, so this is we are talking about like a layer 2 construct, the function here. So which means there's like stuff happening behind the scenes, right? So like it's not only the function itself which is gonna be provisioned here. So we have like 2 level 2 constructs here.
You're breaking up for me here. I don't know if it's me or you.
Oh.
Did I break up? I could kind of see
you.
myself moving, but in both screens.
I can still see you.
Okay. Yeah.
Can you hear me?
Yeah.
Okay.
So everything was all right. You just stuck for me for a bit, and I don't know if it's me, that would be okay. If it's you, it would be worse. But
yeah, I hope it's.
You can see later on.
Yeah.
Oh no.
So this takes a while. I assume it's doing like a bunch of TypeScript compile.
Oh, stream is wild again, apparently. Yup. Maybe better switch your internet connection, Sebastian.
Seems like I can't. So hang on, I'm gonna stop sharing for a second.
Better than typing your Wi-Fi password or something.
Yeah, this, and I'm not sure what the actual issue is here right now.
Okay. Every now and then, kind of.
Every now and then, yes. So I actually switched prior to the stream to the network. I was hoping to be more reliable, but it didn't seem to help. Let me quickly check if, like, which kind of issue that is.
Live demos. At least the code works. So.
Yeah. At least the. But the stream seems to be okay.
Now it's stable. So as usual, the screen sharing issues.
Better no or no. So you can see and hear us. Oh, I believe this is. I believe I need a new MacBook or something.
There's the reason. But yeah.
I have the hunch that this might actually be when I do some CPU heavy stuff like compiling TypeScript and downloading Terraform providers, and Terraform providers downloading probably takes up some bandwidth as well.
Well, it's Node.js for some parts, so it would only take Terraform, not probably, but Node.js would only take a single core, wouldn't it?
Yeah, true.
But still.
that's what I did. And I'm now hovering at like 50% CPU, 60%. Yeah, I think it's like the combination of streaming, screen sharing, VS Code live share, and stuff like that.
I could exit that live share if that helps, but
yeah, perhaps let's stop that live share.
And I'm gone.
Remote Explorer. Live
share. Yeah, I pressed that button also.
So, okay, so back to where we were before.
What did you do? I missed that kind of.
Yeah,
so
right.
You had me at the terminal. Or got me back.
So what I'm doing here is, well, ignore all the noise before here. That's just my my way to get credentials into my commands. And CDK tf-diff is the actual command which we're running here. And now that I'm thinking about it, we might. There you go. Let's see noise. So I ran a diff. In the example project, and so we see like a few resources being provisioned, and one interesting one is certainly the AWS Cloud Control Api resource, so which is like a resource of the AWS provider, and it just takes arbitrary JSON, I believe.
Yeah, it takes the desired state and then matching schema, but yeah.
All right. So is it like a collection of, or like, do we have like one resource per? Yeah. Is it like a one-to-one mapping, or is it like a one-to-n mapping? You know, like a one cloud control Terraform resource and many AWS CDK resources, or is it like?
For those that are supported by the Cloud Control API, yes. So there's just a single Cloud Control API resource. So AWS _ Cloud Control API resource. And that one takes a desired state, which is a stringified JSON. That was some fun.
So this one here.
Working with, yeah, that one. And a type.
And a type. Ah, right.
Yeah. But I get that from CloudFormation, from the schema. So it's in there as well. And also the properties that are set. And they have this...
But it is like a one-to-one mapping, right? So like we have
between those two, yeah, but I thought that you... so there's the AWS Cloud Control Terraform provider, which is separate from the AWS Terraform provider, which has separate resources for all those, for all resources, and uses the Cloud Control API to deploy things. But there's also just this single bucket, one size fits all kind of thingy that's in the AWS Terraform provider.
Okay, yeah. Okay, that makes sense. And so the reason we only see one resource here is that actually only one resource is supported by the Cloud Control API, and all the other resources, like the CloudWatch event rule, the event target, the IAM role, the Lambda permission. So these are all resources which are essentially, well, backfilled from the existing AWS provider.
Yeah.
Okay, but still, like when we compare this with our code base here again, so we have like two resources here, and we provision essentially like a handful, like 5 or so. I see a time sleep here. What the hell is this?
Whenever you have problems in your code somewhere, you put a wait or a time sleep. That's what's happening here. So the explanation for this is that the Cloud Control API expects resources to be there at the time when you talk to it. And for example, the IAM API that's used by Terraform is eventually consistent. So if I use the old school IAM resource with Terraform, as it's not supported by the Cloud Control API yet, as you said earlier, I say, well, create a role. I need a role for my Lambda function. And Terraform provider says, all right, I created it. Here's your arm. And then I tell the Cloud Control API, okay, create a Lambda function for this arm, with a role with this arm. And it tells me, well, there's no such role. And then it explodes. So I put a time sleep in between that kind of delays this by 20 seconds every time. So it's a very nasty workaround. But as soon as the Cloud Control API supports IAM, those will be won't be eventually consistent anymore, and that one could just go away.
Awesome. Okay, so it's like a temporary workaround around eventual consistency issues.
And as I've heard, this time sleep resource, reading the docs, is exactly for this case. So this could also happen if you mix Terraform providers that are eventually consistent or not. So they behave differently. For example, if I use the Lambda function, the old school one kind of from the AWS Terraform provider, the Terraform provider implementation will actually do some bit of back off and seeing this for 400 error from the AWS API for the role, and we'll just retry it for a bit to work around the same issue, kind of, but in a different way. So it already handles that. But yeah, so what I want to say is might still be useful for other parts in the future.
Yeah. Okay, that makes a lot of sense. So when we look in what is generated, like the output, like the synthesized output of the stack, we see, yeah, exactly what you just told us about. Like it is a time provider which is responsible for the delay.
Are you having Siri having fun?
and the AWS provider.
Yeah.
Yeah. So and here here's the resources, the sleep resource, and the cloud control API resource with the desired state, and so on and so forth. So like everything is one Terraform workspace. It's all in the same directory. And well, in theory, that's the thing which I haven't done so far, which we haven't done so far is, but we should be able to deploy this and then actually see like a Lambda function. By the way, like what's US West 2? Okay.
At the time I wrote this example, that was the only region where the Cloud Control API was accessible. So that's
just curious, like where we have to look to find this.
Ah, yeah.
So that's this one here. And we have the Lambda function service. Well, that's a different thing. But we are still in the planning phase anyway. So yes, let's do this and see what's happening. So we have a sleep of 20 seconds. So this should take roughly, I don't know, 30 seconds. Maybe.
At least 20. But yeah. Yeah, time sleep. Go!
So see, okay, the IAM role was provisioned. It's sleeping now. The Cloud Control API is still pending. The target is still pending. And when this is done, this should be, yeah, there we go. It's
works all according to plan.
And let's see what we see here. We see nothing. Why is that? It is US East 2. Yeah.
That's interesting.
Is this also eventually consistent?
No.
Let's see. USS 2. Was this a stack?
I would vote on the wrong AWS account, but
hang on. Let me quickly check. I was pretty sure that is the right one, but I might be wrong. No, that seems to be the correct one. USS 2.
You could compare account IDs from the Terraform state, which is, I think, local, is it?
Ah, that's a good point, yeah.
Or you could call the AWS CLI and do some describe, look for Lambda function with the same credentials that you used for deploying. And if you see it, then you still wouldn't know where it is, but you know that it exists.
Well, let's have a look. Where do we see the account ID? Do we see this somewhere?
Oof.
No.
In some ARN, probably, yeah.
But that seems to be the right one. Yeah.
Oh.
That matches. So what I'm wondering is there like...
Maybe the region did not apply because it was due to some reason overridden by some environment variable or something.
Oh, that
maybe if you set an environment variable that could override what you... I'm not sure whether that would do that. I think you need to exec that one. If you do the AWS export credentials and it's only in that scope, kind of. So like do the previous command.
But... no, I see what you mean. Yeah, absolutely right.
So it's very dangerous.
Yeah, I need dedicated setups for live streams. That's always a bit tricky.
Maybe you could also write the region of the AWS provider to an output or something in Terraform, so that you would kind of get that. You could use a data source for that.
Hang on. I'm just trying to find... here we go. Yeah, I think in my profile, my AWS profile is actually setting a region. Yes, is it setting a region? A region, yeah, it is setting a region.
But this could be improved, so we could issue a warning whenever you have the region in that place. And
I was actually surprised that this is overridden by the environment. Wasn't really expecting this when I set this explicitly in my provider, but that's probably how the SDK works.
Yeah, this provider or access whatever key chain priority blah thingy. Yeah, there's a word for it.
So, but I think I fixed it. And we have the opportunity for another deployment.
So deploy it again.
Yes.
What happens if you change the region with the previous resources? Would be deleted in the old region, probably.
Wouldn't be deleted, no.
Okay.
So there would be, well, they would just stick around. I mean, the AWS provider can't access them anymore. I mean, let's try it out, I guess.
Yeah.
You don't need the diff, you can do the deployments right away.
Could also put the auto proof and just say go. But yeah.
YOLO.
Yeah, exactly. We should add that. You could also have a shortcut for that. CDK TF deploy YOLO. That would be a nice command.
No, but I mean, it's probably just overriding the state, and it's probably ignoring the existing, since it can't find the resources anymore. It should just be...
I would guess that it stored the ARNs or IDs or whatever of the resources and that they contain region information and could delete them. But I may also be more than wrong. Or are your access credentials scoped to the region even? So have you got some high security thing there?
I was just thinking.
We'll see whether it deletes something.
Yeah, we'll see. Yeah, we'll see. No, it's probably not scoped to region now. I mean, I should do this, obviously.
Nothing happened, by the way. It's done. Your terminal.
Nothing happened.
Yeah, it says no changes. You could do a destroy and a deploy, but and the default. I'm very delighted that the adapter itself did not break, although it's experimental.
That's interesting.
But we're on a hunt for resources. Where are they? The void.
So let's see. Then let's see if we.
What's your go-to region? Mine is EU Central 1 due to no reasons.
My guess is US East 1.
Okay.
So how is it named? Since I think there are like a bunch of Lambda functions in there. Oops. It's called Lambda.
Yeah, that helps. But the stack is called cron lambda something, so cron might help.
No. So we have a mystery.
Let's add a Terraform output with a data source for the region. That one takes the region the provider uses. If you use an output, you could just plain see it. If you use a variable, you.
I thought it was a variable, like an output.
Yeah. Yeah, it makes no sense having this variable there in this example. I'm sorry.
Value. So, and what do we want to put there?
I would put in a new data source. You could even do it inline. New AWS region something. I don't know what the name of that data source is. I would maybe type something like region and try to destructure it out of the AWS adapter. Data region, maybe? I don't know.
CDK libs, that's not what you're looking for. So you're looking for the AWS CDK adapter,
right? Yeah, so at the top, if you go up, you could also destructure in line 11. So the AWS CDK package that you have also publishes the whole AWS adapter, AWS provider.
Oh, right. Oh, that's handy.
Yeah. So just region. Maybe it's data sources. So it's in the data. No. You could. I think it's scoped to data sources because we are having namespaces. Yeah. And
I see. Yeah.
Good that we are not live sharing, so makes this more fun.
Does this take anything? No. Option provider.
Yeah, use the default by not passing anything.
And then let's see if we have. So I vaguely remember that we used to have a bug around Terraform outputs. So if the Terraform output is the only thing which got added, nothing was changed. I'm not 100% confident we have fixed this.
That's a +1 for solving that bug. A very public one. But yeah.
Okay, but like think about this logically. Like, where could this? I mean, we do have an ARN for this resource, which is this one. It clearly says, oh, hang on, no, that's a function name. It's a lambda permission.
Yeah, but that's the ARN of that function that we also created. So it's from the other resource, just.
Yeah, true.
So it will be the same problem.
So it clearly says Terraform, it clearly says US. Hang on, I think I know the issue.
Yeah? Got some browser plugin that hides things for live demos?
Well, I confused US East and US West.
Oh, I did not get that.
As most of the times, the problem in this case stands approximately 90 centimeters before the screen.
Yeah, now you need to remove the filter.
And there we go.
Oh, that's I could have told by the name. So
capture name.
Yeah, that's because no name was specified at all. And actually, I think that's what I'm not sure who defaults to that, but
I mean, it sort of makes, well, I mean, it would be nice to have like some sort of name in there, like some like
I don't know what you mean, BW.
Like to some extent identifiable, but at the same time, it's quite handy to have like just like an auto-generated suffix to this.
Yeah.
And okay, awesome. So we do have found it. So we found the resource, and this makes it way easier to actually see what we're doing here.
So the good thing is this took longer than everything else, so must work to some degree. But yeah.
Right. So we deployed this, everything worked. It was not an issue with anything we wrote here. It was like totally my fault for confusing the regions. And so
I think you wanted to talk about 2 resources in existence and it deployed more of them.
Yeah, exactly. So, I mean, we saw that this Lambda function was actually deployed via the Cloud Control API. Is there like an actual interface? Do you know this? Do you have an interface for the Cloud Control API? Like
UI or?
Yeah.
I don't know. I don't think so.
I was just wondering if he can, like if you can just visually see this somewhere. But anyway, and so the other stuff here is like was provisioned via the actual resource in the Terraform AWS provider. So how does this work? Like, I mean, it's like 2 different sources, 2 different targets. How does it actually work to split, like, to have this split between the resources, and like what if we want to add something new here, like and now we want to hook this Lambda function up to some stuff like an API gateway or like an S3 bucket, like as a trigger function, or I don't know.
Yeah. So what we already saw in the API docs for the Cloud Control API resource, there was this type that could be AWS : lambda : function or something. So the type, this is a lambda function, this is a S3 bucket, whatever. And what we do is we take this one, and with the Cloud Control API, there's also the list that you had opened already, I think the 2nd or 3rd. There's also a list of those that are supported.
Yeah.
And we also have that. So if it's supported, we pass it to the Cloud Control API resource. And don't expect an error because it's supposed to be supported if it's in this list. And S3 bucket is supported. Talked about this earlier. And well, if it's not supported, we use manual mappings. So we kind of have a function defined. So we ship some of these mapping, for example, for the AWS events rule and for the IAM role that's also created, which is not visible here, but done by the AWS standard function layer 2 construct or level 2. What's the right one? A2, that's correct at least. But yeah. And what we are mapping is we take an input of an object of JSON-like CloudFormation. Those are the properties that are supposed to be set on an IAM role or on AWS events rule. And we use them, convert them to the format that's used for the Terraform AWS resource, or the specific one that matches the one we want to create. And then we instantiate it. So it's like, yeah, some manual writing involved there.
Okay. So.
And that is the part that maps the resources. There are also intrinsic functions in CloudFormation, but that's another story, kind of. That's also happening.
Yeah. Okay, so like if you would want to, I don't know, do we have an API gateway here? Or like, oh, there's actually, but I'm not sure if you have all the resources which we need.
Might be interesting to get into the stage where you combine them. So I know that DynamoDB is not there because one of our examples I did on that. Yeah, the usual table is not there.
Right. Okay.
So
so if you would add like a DynamoDB table and like make it available as the like I don't know environment or something here in the Lambda function.
How would that work? Sorry.
Exactly. Like how would that work? Like would we like so we would use like a I don't know. So like just try it, I guess.
Yeah.
DynamoDB, and so I love it. Yeah, looks good. Copilot at its best. And almost, I don't know, is it correct?
I think the removal policy is optional, so.
Okay, let's just drop this. So we have this, we have that. So it's not supported by the by like our adapter.
Yeah. Could go table and then.
Yeah, I'm just curious, like what it's taking here.
I think all caps.
String. Okay.
That's nice.
Yeah, that's how I do all my coding these days. Just tap, tap, tap.
That's why your PRs look the way they do.
Best practices aggregated from GitHub, essentially.
What do you do all day then? No. No, man.
Homer Simpsons with this,
yeah, with this that's pressing the key
when
he
you
does.
target on tap.
So the Simpsons did home office. Yeah, do synth. Let's see what happens.
So when we synth this, this, I don't even know what I did there. Oh, a deployment.
Interesting.
Anyway, let's ignore this. We don't need anyway.
By the way, that error was exactly the one that we recently saw reported with two snake case stuff.
Oh, okay.
Mm-hmm.
Or like, Oh, you mean this like call stack?
Yeah.
Call stack thingy.
Yeah, where there's some deep recursion happening or something. Or not deep, but some
But we didn't
recursive
change
data
anything.
structure.
Oh yeah, sure. We did change the output, right?
Yeah, and now we're on an old version. So, oh, we are passing the whole output in there. We would just need to pass like the dot region or something from it. So this is how you can provoke this.
That's okay. That's the.
But we can remove this anyway.
Essentially, I will save this for later and.
Yeah. Nice.
found a case for this at least.
So this now is work time. Nice. So synthesizing. Wait for the error.
So again, so we expect like an error for the DynamoDB table since it's not.
Yeah, if you got your lint right. Yeah, you just removed the output.
Yeah, and why is it still complaining about?
Because the default is very aggressive about unused.
Yeah, I frequently change this after.
Yeah, me too. But I think it makes sense as a default because it catches errors you might not catch if you expect other things to happen.
Yeah.
But for demo projects, that's annoying. That's right.
Yeah, it forces me like when I just like explore something, then it forces me to keep everything clean all the time, and that's lots of imports and like unused variables and stuff. So that's it's usually getting just in my way when I'm actively iterating on stuff.
Yeah. Hopefully.
So that's an error we actually want to see. Oh yeah. Should be created in the scope of stack, but
you passed this, didn't you? Or Copilot passed this. You need to create it in the AWS adapter. That is the AWS CDK construct complaining that it can't find an AWS CDK stack, I think, because it's instantiated in CDK for Terraform land.
That's what. Yeah, I see.
Yeah.
That's what we are talking about initially. That the scope is different.
Yeah.
Okay, I would have taken a lot of time to figure this out.
Yeah, you're right. And the bad thing is we can't easily detect this because that's happening in the AWS construct after passing it. Oh, we could detect that error and then change it to something that helps a bit more. So we can. Yeah.
Okay, cool.
That's a good thing, yeah.
Then we use the AWS adapter here.
Yeah, soon Copilot will also know that. So,
so make sure to publish it on GitHub right after.
Oh yeah.
So Copilot can learn about it.
Yeah, still expecting an error, but this time the right one.
Yeah.
So.
Why is this taking so long?
I thought so too, and I don't know the answer.
So is it compiling the entire provider?
No, it shouldn't be.
Shouldn't be, right?
Because it's. It does because it's a node dependency, so it's loading everything probably. But yeah, this is the error we wanted to see.
Unsupported resource type AWS DynamoDB table.
Yeah.
There's no custom mapping registered for the AWS DynamoDB table. So file an issue. And okay, no, I don't want to file an issue, but I want to do it anyway.
Yeah. So we have docs on that.
Okay.
And the good thing is the docs are with an example for resource known as DynamoDB table. So should be familiar. So if you, I think it's the AWS adapter part there. Concepts, I think. Create and deploy. Create and deploy. So.
Okay, so requirements install the adapter, use the adapter.
We did that.
We did that. Dum, 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 dum. Write manual mappings. This are perfect.
Oh, DynamoDB.
I think
Who would have known?
Copilot was at work here.
Yes? Was it exactly the same? No.
Okay, so Okay, we saw that error. Perfect. I can what? Just copy this?
Yeah, copy this.
And just stuff it into the stack here, or?
Yeah, below your import, not into the stack.
Right. Okay.
So this needs to be called before your code is synthesized. So you could also put it into your construct if you want to, but I would put it separately.
Okay, so let's just do this and see what we get here.
Yeah.
Run this again.
And this example, so the docs walk you through how to build this. So we just copied like the first step that logs it. So we have a look at what's happening here, and it returns null. So this shouldn't error anymore. Just log, oh, this, you should handle this, and that's about it. So you could also skip a resource by doing something like this. But you would skip all types of these resources, kind of. Where you could depend on the inputs and change and just leave out certain ones. But I think that's not a pattern I would recommend.
Yeah. Okay, so this looks different. Command output, standard out, no error, pretty much as you described.
Yeah, it failed somehow with something else.
No, it was like the scrollback, I think, or?
No. But it's, we didn't map anything, so it's okay that it still fails. Yeah, and that error is also explained in the example. So there's a safeguard in there. So whenever you map something that's passed in the properties, in the props, you also need to delete it from that object so that we later on can see whether you handled everything. So for example, now you might only want to, for example, handle the DynamoDB table, table name, and some attributes like time to live or something. And if you then have this mapping in place and would take another resource that sets more properties, like some whatever retention strategy or something, then that would kind of silently drop that, and we don't want that. So we want to be or the mappings to be explicit about what they handle, so that later on you don't need to implement everything at first, but as soon as you stumble upon something new that you pass to the construct, you need to explicitly handle it, kind of. So that's why you need to delete from props. And as we did not do that, there were keys left that are not undefined. And that's why it's throwing an error and saying, well, you did not handle everything.
What does it mean? I can just take this and map this and I'm done?
Yeah. So you also need to import the DynamoDB table resource. So line 12. Oh, that's not enough because you have, yeah, you took me by word there. That's something we could also do. I wouldn't make you write that code manually, but okay. You kind of still need to pass the type as well. So I think it's DynamoDB as the namespace. Yeah. And then
what?
in line you could comment out the big chunk you put there. Return. It's nice to keep that in place. And now you could go and return new DynamoDB.DynamoDB table. Yeah, the global one is supported, so that one.
So like scope.
Yeah, underscore scope,
ID.
or not underscore.
Let's get rid of the underscore here.
And for the ID as well.
Okay.
And props are the ones that you need to map, kind of. So I would create a new object that's maybe called like new props or converted or something. And just make that an empty object for now. And pass that instead of props in the next line. Yeah, and now you can see that, for example, key schema is something where some attributes ended up in. So you would need to map that so that it matches the schema that the DynamoDB table resource of the AWS provider supports. So one thing that helps is if you would type your converted to the DynamoDB table config type. That's also in DynamoDB.DynamoDB table config or something. So the type of converted, basically. Because now you get all the nice hints and everything. So.
Okay, this doesn't work, but we have table name SSC.
Exactly. And what you, just to quickly bring that to an end, you would need to do afterwards, and like line 22, would be to do a delete props.table name. So you delete table name from the original props. After that, not there, not there.
Actually, like, okay.
Separate statement. So no, there's the JavaScript delete property, which is the same as setting to undefined. So you could also set it to undefined. So you need to make the reference to props empty, kind of. So the original one.
That's what you mean.
Yeah, and that's the same as doing delete props.table name semicolon.
Ah, you mean like?
Yeah. What you never use, or I never use. So. And this way.
So why is that? So because there's a check which checks for like required attributes, or any attributes which are left and unmapped, or.
So in the AWS adapter, there's a check that checks this props object that it passed to your mapping function, for any leftovers, kind of, that you did not map. And by doing it this way, for example, if you had an DynamoDB table that only uses table name, you would be done by now, and everything is all right. And then tomorrow, when you add a new table name or DynamoDB table to your project that sets, like key schema, as in this example, then it would fail and tell you you did not map key schema. So it does this instead of silently dropping things. So this allows you to not handle everything from the beginning, but it would still remind you when something new appears that it cannot yet handle. So that's why. And that's something that I took from the original prototype. So that's, I really like that. So yeah, and the joy part about attributes and the CloudFormation versus Terraform is that they look vastly different. So yeah, but that might be a quick name. But attributes itself is an array of objects with type and name or something. So that's, I don't know if it's, I don't know if it's type name, but. Maybe it's not even attribute, but they differentiate different ones. But maybe have a look at DynamoDB table config.
Oh, we don't have attributes.
I think it's different.
So what are we mapping here? We're mapping the attribute name.
Maybe it's called schema.
What is attribute in this case?
Oh, attribute is a block. So it's called attribute, but it's still an array of, so you can have multiple attribute blocks in Terraform. It's name and type, but it's still attribute and not attributes.
Okay.
That's confusing, right? Yeah. But it has to be an array because you can pass it multiple times, and in HCL you can pass it multiple times, but JSON or JavaScript does not like that at all. Yeah.
Key schema, attribute definitions. Hang on, no, I did something wrong here, right? Attribute definitions. That's not key schema, that's attribute definitions.
Mm-hmm.
And then it's attribute name and attribute type, table name, key schema.
I think it's just the name, yeah.
Yeah, that should work. So, and these are the required attributes which we need, or like all the properties for the DynamoDB table.
Yeah.
To make this work, we can get rid of this.
And the key schema.
And this one.
Yeah.
Okay, and this could, in theory, work.
Yeah, you still got the time to live.
Yeah, I didn't get that either. Oops.
Yeah, writing manual mappings is hard, but this is only something you would have to do in the meantime until the Cloud Control API supports like DynamoDB. You could just drop those mappings and live happily ever after.
Yeah, so I was just talking to Siri, which went like, I don't know, but prompted something, I don't know.
I disabled it.
Yeah, no, sure. Like that's like a temporary solution to the fact, or like to the problem that the Cloud Control API is not supporting all resources. But over time, this will hopefully catch up to like 100%. And then you could essentially just, well, like either we have like, I think like we do have mappings for like a few core resources already, like, you know, like identity access management. The demo cases which we saw here, and I think that there might be perhaps some stuff added there. Probably also like a great opportunity for contributions.
Of course.
If people feel like adding a few things, a few mappings here and there, this would certainly be helpful. But yeah, like eventually this won't be necessary anymore, and we still see an error.
Yeah, you still did not map so time to live specification, but that's also optional, so you could also remove it from your sample table. I think it's optional.
So what do you mean as we could do this?
Yeah, or delete it from the source, kind of from your main, from your further down below where you use it.
I see.
You just took that from CodePilot, but you didn't need to.
I see.
But yeah, this can be quite complicated. There are also some resources where they don't map one-to-one between Terraform and CloudFormation, but you got multiple resources for Terraform and just a single one for CloudFormation. And there are also some and that are the tricky ones, where you have a separate resource for CloudFormation, but none for Terraform, I think. And you kind of need to change something for an existing resource, kind of. So the VPCs, that's some weird stuff there. But what was the error?
Provisioned throughput.
Oh, because that's set by default, even if you don't pass it, right? Okay.
Probably.
You could also delete it. But this would be you saying, I don't support this, and don't error when this appears.
Yeah, for now, that's exactly what I want. Yeah. So we saw like two other examples. So which means there's like more resources covered than just Lambda, and or like which we know which should be working.
Yeah, but only a few. So if you were to use this experimental new adapter, I think like 99% of the time, if you don't want to deploy the same Lambda or the same resource that our example has, you would need to write custom mappings for now. We're happy to take contributions and also to add some for you. But yeah, so
We have no
yeah,
attribute.
That's the next thing. So there's mapping between how the CloudFormation schema does relations between attributes, and there's also the way Terraform does it. And for example, in your example, you pass the table name to the Lambda function, and under the hood, this will resolve a reference to that DynamoDB table you have. So your mapping has one more thing, which is called attributes. So this one, and there you would add like ref for this example, and
like as it's written here.
Literally, yeah. Ref, and with a capital, yeah, and that's getting the function, the DynamoDB table. So the argument to it is table, for example. You could do table and also type it to dynamodb.dynamodb table. Yeah, and return.
It's listening.
Yeah, return table dot, not what it says, because that's CloudFormation. That's exactly what CloudFormation would do. Scary. Return table dot arm, because that's how you reference a table, DynamoDB table, Terraform. That's the ref for the table. I think, how did you pass the table name as an attribute further down? It will probably also ask about a similar thing soon, but let's run it again.
Do you mean we need like yet another attribute?
Yeah, table name probably, and then you would do table name on .name and for Terraform.
Oh, right. So not only the references has to be mapped, or like essentially like all.
Not. Yeah, because we don't know how they are called in Terraform or what they are called in, and that's the great thing about the Cloud Control API, because with those resources, they are called exactly the same.
Yeah. Since it's like CloudFormation spec.
Yeah, so from a Cloud Control API resource, you get a JSON, a stringified JSON that contains everything.
Seems to work.
Okay,
Like
whatever you did,
like the
pass
SID at
that.
least did work. But I'm curious, like what it actually generates here.
Maybe table name resolves to a ref, so it will do the ARM thing.
Table name, yes. Good guess.
Yeah.
Which is not really what we want.
It's,
But help me to understand, like why, since like we didn't map name here.
yeah, but if this one does a ref, maybe in CloudFormation, a ref to a DynamoDB table is the name of the table. I don't know. So .table name, maybe there's also .name, and that will just return that.
So what you're saying is I can't, like this wouldn't help.
No, because these attributes over here, they resolve what CloudFormation creates as references. And you would kind of need to find, there's .table, for example. You would need to, yeah, I think you're somewhere else now, deep in the implementation of that one. So you could use IntelliSense from in main.ts on the .table name.
Yeah, physical name, table name.
Ah, okay.
But yeah, not sure how the references are, like would be working here.
Yeah, I would start running this and printing whatever's in there to figure out what exactly is supposed to happen.
Yeah. String to CloudFormation table name. But
Yeah.
like, I don't know. Shouldn't this work?
If this is the way a table resolves, you could also change this and return table name. So no, it's all right. The ref is the one that is used because it's resolving to the ARN we have. But what I told you with ARN is not correct for DynamoDB table, maybe.
So this does make a difference here.
No, it wouldn't. But returning something else in line 53 would. So you could do table.name maybe for Terraform.
Since that's a primary identifier, that's what you mean.
If CloudFormation uses this that way, so you still need to
I see, yeah.
know what's supposed to happen. So I spent a bit of time in the docs there when writing mappings.
But yeah, this could be the case. Yeah, when like if it's treating the table name as the primary reference. But how does it work? Like if I would reference something else.
This is only for DynamoDB tables. So if you reference .time to live specification, you would need a new attribute for time to live specification, and that would resolve to table whatever you need to
references in Cloud Control, right? Or like in CloudFormation.
I don't know. I think it's get attribute, and that can also reference different things.
That's the difference.
Yeah, but yeah.
So Matthew. Great discussion. Yes, really enjoying it. So like our expectation would be that we have like a Lambda function which references like a DynamoDB table, and the name appears as the environment variable for that Lambda function.
Yeah.
And let's see what we are planning here. And Lambda permission, where is it deleted?
I don't know.
A rich diff would be nice.
Yeah.
But yeah, so we don't care.
You need to create a second GitHub user and do another thumbs up on the issue.
Oh no, write capacity. Oh, so we actually would have to map it, I see. We could just change the billing mode. That's probably
yeah, but then you also need to map that one. What you also could do is in your result of the mapping.
We should change the billing mode anyway.
Okay.
That was easy. Yeah, what's the result of your mapping?
No, that would have been the workaround. But for the billing mode, you know that it's currently undefined, line 37, but it will soon be there. So I think you can basically pass it. So it should be very similar. Yeah. And delete it.
Oh yeah. So does it mean, like, could we do some auto mapping here? Like, you know, okay, hey, we like essentially at least provide some generated defaults, you know, like, okay,
yeah,
that's how this could look like, and it's probably right in 80% of the cases.
Yeah, we could. When working on mappings internally for the adapter, I have a create guessing resource mapper that takes further arguments, but does exactly what you just proposed. So it does the casing changes and passes it along. But yeah, we could do that. We could propose more, but that wouldn't work in all of the cases, and we can't be confident that it does. So this way is the safe one.
Yeah.
But yeah.
Yeah, sure. No, it's like, you know, just like scaffold it out, like that we.
Yeah, we could print the code that the user could paste, and then
exactly,
it does not work.
And then you have to adjust the stuff which is not working.
Yeah.
And drum rolls. Looks like we got our Lambda permission back.
Yeah, weird. Oh.
Model validation exception.
Maybe whatever you passed as the environment variable is not valid.
Very likely.
Yeah.
But the only question is like, okay, what is what would be a valid environment variables, table name. Okay, no name, okay.
Yeah, we should make debugging simpler for these things.
Okay, desired state. Okay. Just key string. But that's, I mean, I would expect that this is working.
Mhm.
Model validation 400 and line 96. But yeah, I mean, we don't have to. Okay, 996 is not really helpful, but it's probably talking about the desired state here. Since we didn't change anything else. Oh yeah, sure, we did change. We did change the billing mode.
But that's not the lambda function.
True.
So I just checked the cloud formation schema, and it appears that variables and key value map is all right. So
so maybe it's not resolving, but no, even then, I mean, I don't think there's any invalid characters here.
Maybe that's the same JSON bug that I just fixed today, that we had with cloud, with the step functions, because that is nested JSON inside this JSON. And that was some issue. So this is probably not properly escaped, and cloud formation gets, or the cloud control API gets something that's not valid JSON that it cannot work with. So we're trying to set a string instead of a key value or something.
Yeah. Well, then let's do it.
Let's see that the table at least gets created.
Yes, let's see that table name. Okay, what we see is, and you just mentioned, okay, there's like a bug which got just fixed.
Yeah.
It's just not
released
or
yet.
is it like a pre-release? I don't know. But yeah, it's going to be released with the next major, like minor release. That's when it's like generally available, like the fix. And
yeah.
And yeah, so we saw where we can map things. It takes a bit effort to do so, but essentially you have to do it like once per resource. And well, the list of resources might increase over time, like which are supported like out of the box, and like both like on our end and also on the Cloud Control API end. So this will get like a bit more streamlined, or like way more streamlined, and interesting. Some referencing issue. Anyway, let's not dive into this rabbit hole right now.
We had enough rabbit holes already.
We had like a few rabbit holes already. But yeah, I'm still very, very excited about this. And I'm like, one last question. Like, I see inline code. Would I be able to use like assets in any other way, like use the assets feature of the AWS CDK?
Yeah, that's something we need to add support for, because we have a different way of handling assets in the CDK of Terraform at the moment. But that's something we got on our roadmap for the adapter, so that we also support like Docker assets or bundling up functions and not having the inline code existing artifact, which is like the easiest way to support because it's just a string in CloudFormation. But yeah, in the future, that's something that has to come.
Yeah.
And also cross-stack references and similar things like transforms and includes that supported in CloudFormation and might appear in AWS CDK resources. Possibly not, but it's also such things.
Like I think, like in a nutshell, like we can use constructs from AWS CDK.
Yeah.
And really just constructs anymore. So no stacks, no nested stacks.
Yeah.
There's no asset support really at the moment. I mean, that's something which we like think about, like how this, like in particular assets, is certainly interesting.
Yeah. But it's experimental at the moment. So
yeah, exactly. It's experimental. So like at the moment it's really constructs and really only a very limited subset of constructs.
Yeah. Yeah.
So it's more like the general idea of, okay, that's how this is going. Like that's the direction where we're going with this. And
yeah.
And
that's
like
an answer.
Very early. I think it's really exciting to see this path forward there.
Yeah, I just want to say that's an answer to how we envision like layer 2 with the using the layer 2 that exists, kind of.
Like
yeah.
For it makes a lot of sense to just reuse existing code, where the AWS CDK team spent a lot of time building this. And
not gonna reinvent the wheel and IAM permissions and all those.
yeah, true. Awesome. Thank you very much. We had a lot of fun. I had a lot of fun, anyways.
I did too.
And yeah, really looking forward to see this growing and to actually use it in, well, more elaborate use cases. And
yeah, can contribute mappings all over the place.
yes. Yeah, I think it's like in the end, it's like just
it's a matter of time.
20 resources, and then it's like what people, or like what I would use normally anyway. So like I think it's not that much which is missing there.
Yeah. And the good thing is, over time, we need to include less and less mappings.
Yeah.
So
they fade out over time.
Yeah.
Perfect. Cool. Thank you, Ansgar. It was a pleasure to do some live coding with you, and looking forward to, I don't know, the next iteration somewhere down the road. And yeah, thanks for your time.
Yeah, thanks for having me.
Awesome stuff.